Happy Monday. How's it going, everybody?
It's going well.
Cool.
Yeah.
Yeah.
Good to meet you, Ananth.
Hey, good to meet you.
Yeah. Hey, how's it going? For people who don't know who you are, do you want to give a quick intro?
Hey, hi. So I'm Anand. I'm currently working for Zendesk right now, where most of my focus is on customer-facing analytics. So in a nutshell, what I'm trying to build in Zendesk is like think of a database for customer experience. Right? So working on the customer-facing analytics, building all the cool stuffs in Zendesk. Rest of the time, I read a lot. I write a lot about data engineering. And I also happen to write Data Engineering weekly newsletter, just aggregating some of the fun reading that I'm doing, sharing with the world. So
that's cool.
What's your strategy for writing? I'm a bit curious about this because Joe and I just basically finished our book. Like we were even doing more writing this morning, but it's not easy to like discipline yourself and create the time to really generate good content.
Yeah, it is very tough sometimes. Like, especially today, actually, I wrote it just now because I missed in Sunday and I am in the middle of moving, family time, sort of like that. It's pretty tough. But overall, I really enjoy reading more than like writing. So I love to read like what other people have done it. Like I'm kind of an observer, not like a self-creator myself. So I just try to love observing a lot of different thought process from different people. So it's kind of a way for me to structure a time to learn things. So writing is like a byproduct out of it. So it's a good byproduct to have anyway.
And so you read, and then is your strategy just to say, oh, this idea seems interesting, or what if we combine ideas A and B and then just start cranking something out? I know when you draft things, it's pretty raw sometimes. I find that it's good to start with a very just like throw it on the page, see what you get, and then go back and edit and pick out the good stuff and make it into something good.
Not like every day I kind of read through. I mean, I have some few parts that read articles and get those or aggregate those links to me. So I just kind of glance through it every day and see what is happening. So I just whatever is like, oh, this looks interesting. I just pin it for some time. And when I'm writing, I'm just kind of recap everything and to understand. Like, and that gives like a full-fledged pattern of learning, right? Like, I mean, 2-3 people might have reflected a similar thought or reflected in alternative thoughts. That gives a very good learning practice of understanding from different perspective, the pattern learning, stuff like that.
That's really cool. I mean, there's a lot of data content out there right now. I mean, how do you, what's your process for curating this? Because I do the same thing, maybe similar-ish. I probably read probably a few articles a day, and then on the weekends, my iPad's queued up with dozens of articles that I just go through. What's your strategy for, I guess, reading productively and curating?
I mean, like my first trade is always like kind of quick glance through to the end to end, like, because you have some kind of a domain understanding, that, okay, this is worth of reading or it's not worth of reading further to do that. So that will be my first filter. And then some interesting concept, I'll take time to read through fully to get things, get more clarity on that.
Interesting. What are some of the big themes that you're seeing right now in the field of data engineering and data in general, I should say? So,
I think the big pattern right now I'm seeing people are like there's two sides. There's a huge group of people who is kind of very interested in what is a modern data stacks and whatever the promise of it brings in. There is another camp that says like the economics factor and some disorganization of these tools bring more and more practical limitations. So I think it's swinging the pendulum in both the sides. Like you have much flexibility that the system, like let's call it like a modern data stack, right? So much flexibility that it gives for you to quickly go from 0 to 1, like a typical Ruby on Rails moment, right? You just buy those out of the shelf product and put it there. I think once the next stage is going on, I think that's why a lot of companies are now struggling, and that that kind of a operating workload is kind of now reflecting. And then I think I think it's a very healthy way because you have to swing the pendulum in two sides to see figure it out where's the central of things that we have kind of figuring it out. I think that's why I feel there will be more and more consolidation. It kind of obviously, the vendors who developing this modern data stacks are like already data engineers in most of the time, so they understand what is happening, and then I would imagine a healthy balance of both happen possibly. I think that's one of the biggest pattern I see.
Yeah, it's interesting because the modern data stack tools are very nice, right? Joe and I have talked about this a lot, how in some sense what we're doing is reinventing things that have been around since like the 90s, but we're making them much nicer. But on the other hand, at some point you start assembling these tools, and like you said, you get from 0 to 1, but then data itself is complicated and it becomes a human problem, an organizational problem. And so the next frontier, I suppose, is like combining tools in a way that reduces that friction between teams and such. I don't know. What do you think, Joe?
Well, yeah, I mean, I think it's the low-hanging fruit's definitely, I think been harvested. But I guess that means that more low-hanging fruit will disappear, different types. But yeah, I would say the movement of data, that's I would say solved, at least for the purposes of what you would call what would be useful for today. And I clarify that by saying what's useful for today is getting analytics, I would say somewhat routinized, right? So pipeline stored and then presented to people. But that's sort of the easy part. The hard part, which we'll get into in a bit when we talk about data contracts and domain ownership and all this other stuff like that. This is the next frontier for sure. Right before our chat, we were talking about the basically the lack of like cost effective, I would say more modern MDM tools, for example, master data management for the audience. That's I don't know. Is there anyone out there doing that? I don't know, but that's just one of many solutions. I would say that over the next few years, like this is sort of the next frontier of where data engineering is going. Matt and I always talk about how we think data engineering is the future of it is to become much more enterprisey, so to speak, where MDM was reserved for big enterprises. But back in the day, guess what else was reserved for big enterprises? Data warehousing, all these technologies that were insanely expensive and so forth. So what are your thoughts, Anand?
Yeah, totally. I think the whole notion of modern data stack, I feel like we were far moved away from a lot of, like, let's say 95% of the use cases is not really served well by modern data stack, or like the tools are not available. Like we talked about MDM is one use case. That's something that we hesitate to take, and maybe, yeah, there are pros and cons of adopting MDM. That's a different case. But there are a lot of industries that require strict regulatory requirements, like healthcare, finance. They need an MDM tool either way. They cannot just adopt a customer data platform and say like, oh, this is probably match the customer. They can't do that. There's like a lot of regulatory requirement in there. And schema modeling from framework, like I was running through some poll essentially asking the same two questions. How many number of people are using MDM or plan to use an MDM? 50, like my sample size is like around 50 people who participate in the poll. 50% of the people almost say that they're using MDM, and 20% of people told they are planning to use MDM.
Mm-hmm.
And schema modeling tools, almost like 60% of people using the Irwin tool for schema modeling. We have not modernized it. I think there's a huge stopgap solution they can give to kind of bring up mini usability to the bringing. I feel like there's a ton of opportunity on that.
Yeah, I completely agree on that front. I mean, one thing we've talked a lot about is that there are kind of two responses to modeling when you talk about modeling. So one camp is like, let's just do everything we've been doing forever. So you're either going to do Kimball or Inman, just use one of those approaches. I don't care if you have a new data warehouse, use what you already know. And the other approach that kind of came out of the GFS Hadoop world was like, oh, we don't need data modeling. That's old and stodgy. And I think the future is somewhere in between. Like probably going to get away from full normalization. That doesn't mean we're going to get rid of all normalization. You need to like optimize for the data and for the tools at the same time. And no one has really done that just yet, as far as I can tell.
Well, and I would say the surprise winner might be something graph related too. I mean, more
quite possibly.
People in the graph database world, I'm like, yeah, I'm pretty convinced that is a different way of modeling or just letting the model do its thing, I suppose. But yeah.
And that's exactly the reason I created Schemata there. It's a kind of a
Ooh.
graphical model in that.
Well, let's talk about that. So I think you
Yeah.
have something you want to. Let me share my screen real quick. Something you want to talk about today, and this is actually pretty cool. You sent this to me, and I was like, okay, I get it. This is dope. Yeah, what is this?
Yeah, Schemata essentially it's a schema modeling framework for decentralized domain-driven ownership, right? So there are multiple. So when you're talking about schema modeling is hard, not because it's hard to learn. It's most of the time I feel it's kind of an opinionated stuff, and it's all it's mostly it's an individual opinion. How you wanted to say that it's an SCD1 or SCD2, how do you want to model it, whether you're going to a data versioning or not. It's all still kind of an opinionated way, and that changes. The second problem I noticed that when an organization at the scale, like for example Zendesk, it's literally impossible for one person to define the data model, right? Like they can't, like no one person can hold the entire data model for a company. But when you have the alternative solution is like you hire a data modeling team centrally, and that's a recipe for disaster, right? Like if you create a centralized governing body, you have to wait a lot for the gaining the consensus, and gaining the consensus is the enmity of latency, the faster that you want to deliver. So I think that's why the schema modeling is kind of take a back step. And the alternative that we end up okay, send whatever you want. That's like a promise of data lake, right? Like you don't need to do anything, put it everything, and then we will try to figure it out later. I call this as a garbage in, garbage out problem. Mm-hmm. The data, the value of the data is directly related to the lifespan of the data, right? Let's say you just put all the data there, and 6 months after that, you're trying to figure it out one data. By the time, the value directly, decreasing as the time goes. So there's no point of keeping everything as it is. And since you just put everything, you cannot really clean it up. It's just like the garbage end of the thing.
Well, it's more like garbage in after a certain point. It doesn't ever leave, actually. It just
never leave out. Yeah.
Right. 1-3 never. Isn't it one of the
it's like the
derogatory
Hotel
terms?
California of data. Yeah.
Just, yeah, totally. So Schemata is trying to find the middle ground. So what it means is that we put the schema modeling in the hands of the domain owners who actually creating this domain to define the logical data model for that. But the challenge with that approach is two things. One is the application developer, the future developers, they're not going to the same conference as the data engineers goes, right? They don't have any awareness of Kimball methodology or the schema design, best practices and stuff like that. The other problem is that, okay, sorry, someone knocking on my door.
Oh, no worries.
Okay, so the second problem is that with the domain ownership and decentralized schema modeling is that data is very inherently social in nature, right? And the domain has to well connected and well interact with each other. Otherwise, there's no use for the downstream consumer if there is no connectivity established. And Schemata is a framework that systematically figuring it out, your schema completeness, how many metadata that you added, and how well connected your schema from each other. So it is a feedback loop for schema modeling back to the data future developers, say that, hey, there is a significant connectivity is missing in your schema modeling, go and look at it. So if you scroll down, I gave an example in the down how that kind of detecting, right? Even further down.
Just tell me when to stop here.
Yeah, go ahead, down, even down. I think it's the last end of it. In the schema score.
There we go.
Yeah, so if you can see this, this is a schemata score is what schemata does that. It grabs all the metadata information and try to build a graph and figuring it out how well connected each and every edges are, and then in a very opinionated way, right? So for example, if you see there is a campaign product tracker event and campaign category tracker event. So if you have a data model, that has a category and product are the two dimension, and you wanted to create some tracking event. In your event, if you connect directly to category, if you link only to the category dimension, the reachability of the category is pretty low in the graph, right? It's in the edge of the node. Versus if you define a product, product tracking event with the connectivity of product, the product has well-connected edges with the brand and the user and stuff like that, right? So now your connectivity is well more established. So Schemata score is dynamically figuring it out, how well connected those edges, and try to score and give some concrete view to a schema modeler or anyone, and to say, hey, this might be an area where this could be a problematic, some critical linking might be missing. So this is essentially not trying to define schema for you. You're trying to point where could be the problem, and by building those, what we call like a knowledge graph out of it, and try to help people to, figuring it out and, atomically make a well-connected data model.
Interesting. It kind of, in some weird way, it reminds me of test-driven development, like kind of schema-driven development almost, where you're
exactly
coming up with schema coverage. Is that completely
Yeah.
insane? Okay.
Exactly. I mean, during my times, like last 1.5 years in Slack, I used to work for monitoring and observability infrastructure. And I used to work for data infrastructure and moved to data monitoring infrastructure, where I brought in a lot of data engineering skills into monitoring. But significant thing that I learned from monitoring infrastructure is like an application should be always developed with a strong feedback loop. If you don't have a feedback loop, it's just like uncontrolled, right? So the exact same concept of test-driven development, or creating a feedback loop and putting into the schema modeling technique. And that's what Schemata is all about.
Yeah, that totally makes sense. And I mean, I think one weakness we've seen in the application development process in general is that in traditional data warehousing, there's this huge wall between application development and analytics. And basically the application developers are kind of told, don't worry about analytics. That's someone else's problem. Just model according to the objects in your software. Don't worry about, someone else will figure that out. And we're strong advocates for a feedback loop between the analytics side and the software development side, especially as we see the rise of more and more data applications, by which we mean analytics is integrated right into the application. It's embedded, it's user-facing, it's dynamic, it's semi-real time. Yeah, so this looks like a fantastic tool to enable that feedback loop through a visual means of interactivity. Yeah.
I actually got a question here from Scott Taylor. Morning, Scott. He asks, basically, what do you mean by domain?
So domain is specific to an individual functionality of a business. Let's say, for an example of Slack, you take there is a search bar, you go and search something, and which means that functionality has to be powered by some kind of a search infrastructure behind the scene, and there is a specific business need for that. So there might be some team that dedicatedly focus on fulfilling that particular business functionality. That collectively we call it as a domain, right? Like search could be one domain, like e-commerce that you can have a checkout as a one domain, and the hotels, people might maintain the hotel inventory, or reservation can be another domain. So a modular decomposition of a business functionality within an organization, you can call them as a domain individually.
Yes, basically, so a department?
Department could be a collection of domains. For example, like you can have an infrastructure department, search will be one domain, or some other could be another domain. Or e-commerce might have a catalog one domain, and then you have a checkout could be another domain. So department can combine multiple domains.
Let me ask this. With the advent of microservices, has that affected how we define domains or not? Is that kind of an orthogonal question, or does it mean that we're going to decompose problems into smaller domains than we did in the past?
The challenge of microservices can define these things. I don't have a strong answer for that. How that changes the domain definition for it. But my opinion, like there's no one like there's no one-on-one relationship with the microservices and domain. They'll always have them.
Yeah, it's interesting. Yeah, I mean, I think the concept of domains, it's been around for a bit. Like,
Yeah.
I think what domain-driven design really brought this home. I think it was in 2002. It was Eric Evans' book, something like that. And then, and data domains. This is, I think, come to light, especially with data mesh. As Mark's book, and the first parts of the book talks about domains and ownership and all this stuff. And it's interesting because I think Schemata actually it does help address, I think, one of the big concerns that Matt and I had with the implementation of data mesh, which was, well, I think it's a wonderful idea and a wonderful ideal, but unless you have some sort of coherence with data definitions and schema, it's very equivalent to API contracts in that sense. And when I know that one of the things we'll talk about in a bit are data contracts, but this is very I think something like what you've written in Schemata is very much a step forward towards making this a reality. Because right now, trying to share data amongst different producers and consumers is like I think a nightmare is maybe a polite way of putting it. I don't know.
Yeah, because fundamentally you still have this question of like who's responsible for the integration, who's responsible for turning that into a coherent picture, and if the individual teams are doing a good job of producing data for their domains, but there's no integration, like your value really gets reduced potentially.
I think I mean I've seen many people are comparing with microservices and the data mesh stuff like that. My opinion, like both are like I understand, I agree the domain ownership, but there's a slight difference between comparing an API interface versus schema modeling interface kind of thing. So API is largely an integration pattern, right? You have a producer produce, this is my output schema going to look like. That's largely an integration tool. When the consumer call it, this is a set of known input I'm giving, and this is a set of known output I'm giving, and that's it. It's purely an integration layer. Whereas data engineering or data pipeline, it's a value stream layer, not necessarily a contract layer, like not necessarily an integration layer. So the downstream consumer is still produce another contract to somebody else, joining multiple other contracts and derive their own insight or derive their own fact and give back, adding this value stream. So everyone contributing to the data pipeline, they're adding value to the whole stream of data that's flowing in. It's not like a point-to-point integration and serve the customer or something like that. So
yeah, that is a good distinction.
Yeah, so that's why that's one of the reasons like kind of a schemata exists in place is essentially the API contract is alone is not sufficient if you wanted to build a data contract. You have to know how those downstream value stream is enhancing those model and how well connected those model. Right? Even though you're deriving a new fact, you still need to join to the core dimensions somehow. Otherwise, the other downstream consumer will not able to get those value pops what they want. So connectivity is a crucial play on all those things.
For sure. This kind of echoes that discussion we had with Samaka a few weeks ago, where we're kind of wondering, okay, so APIs, it's a construct that's been around for a long time now, right? And so, but yeah, I mean, what's next? Because it is, I think to your point, it's very well suited. The protocols, right? Very well suited for applications. But when you get to data, it's kind of like we're trying to shoehorn in things that aren't, I would say, as you aren't going to maximize your utility out of this. So, yeah, that's interesting. Let's kind of back up. Like, how would you define a data contract?
So in my opinion, like, okay, contract by definition is a mutual agreement between one to more than n, like one to n party. That's essentially a contract. I say one to n parties because there has to be only one owner. There should not be no two owner. Like any shared ownership never gonna work out. So it should be always like a one to n relationship. And especially to the data contract, the way I see data contract derived in 3 different dimensions. One is agreed schema that this is a known output that I'm giving, and this is a guarantee that I'm giving. Like if I give you the exchange format, essentially, that's a schema, right? That's the first part. And the second is like agreeable data quality and data completeness between the producer and consumer. I say that is an agreeable data contract between a data quality check between the consumer and producer, because as I mentioned, like the consumer view the data quality in a different way than the producer own the data quality. When they produce, a domain owner produce the data, they have no clue how does that value stream going to connect and create a new fact. What is important, what is not important, what is completeness, what is not completeness. The producer will have no knowledge of it. So that's a significant difference between API and the data contract, is that producer will always, in taking an input from the consumer, adding their basic sanity check, taking the consumer point of view and adding those data quality check. So that's a second I would say like there's a second dimension of it. I think the third dimension is like reliability and availability, essentially. Like because the value stream has a strong tightly coupledness with the timeliness and the reliable way of the delivery of the data. I think these three dimensions kind of agreed on that and agreed within 110. And it's not like data contract is not static. I think that's one thing folks need to be really aligned on. That it's a very dynamic in nature. Every 2-3 days, somebody will, because you never notice there is some issue, and 3-4 days, somebody in the fifth pipeline or the sixth pipeline downstream, somebody noticed something and say like, hey, there's something is wrong here, and your data contract anywhere near. So it's an active workflow. It's not like you sign this DocuSign and you're fine with that. It's a very active workflow. So I would say these are the characteristics.
Yeah, and to me that sounds like an evolution, because when I think of data contracts, I do tend to think of them as more static. It's almost like traditionally it was almost more like designing a car or an airplane. We had these different teams working on systems. It's like, all right, here's how these systems are going to communicate, and then that should never change for that car model year or whatever. And now we're saying, all right, we're still going to have contracts, but we're going to have this communication layer that's visual, where we can see what the contract is, and then I, as an analyst or a data engineer, can say, hey, this isn't quite what I need. Can we evolve the contract some in terms of what I'm getting and change the application to improve analytics?
Yeah, because the underlying business is not going to remain static, right? The whole purpose of defining this, that you are fulfilling some kind of a user request or some kind of a business need, and that is going to change all the time. So the data products that you're defining, it'll always have its own life cycle. It has to go through its own life cycle. As the life cycle changes, your data contracts are always kind of renegotiated, and then the perspective about the data products always change. So it's a very active communication. I think an active communication layer on top of Schemata is missing right now, and I think that's why I kind of call for like more contribution, that building a layer on top of it. And to
what would active communication look like to you?
It could be in a multiple way. Like for example, I think some of the frameworks like Great Expectations has already, DBT testing have already done it, right? Let's say, what could be the renegotiation part? Like you might miss certain field because the domain owner, when they define the schema, they might not aware you need to capture the product name along with the product ID or some kind of a field they might have missed it. Like some ML team might heavily rely on that. So there's a simple, hey, can you add this field? And simple request response model to do that one. Or you wanted to have certain limitation, certain range for, let's say, product ID has to be 1 to 10, and you might not add the kind of data quality check because data product owner may not aware of that there is a range limitation that they need to apply. Otherwise, some kind of a machine learning pipeline might fail. So, adding a new rules of those data quality checks, stuff like that.
So, how does Schemata differ from a metrics layer or a semantic layer?
Like the metrics layer, semantic layer, it's more. Let me think of that, like how that can be defined. My understanding is that the metric layer right now strongly focusing on reusability of the metrics, like a metric definition, and trying to build on top of it. I see a lot of similarity between the schemata stuff and the metric layer at some point of a time. But the focus of the schemata is only limited to define the contracts, not necessarily integrating with any BI tool or trying to build some kind of reusable metrics on top of it. So and the other thing that I am not able to tell that I have seen any metric layer in commercially available yet, like people actually using it. So that could be one of the other reasons. Yeah, right now from a pure modeling purpose perspective, there's a lot of similarity between them.
Interesting. I don't know. Yeah, I mean, it's one of those things that Matt and I kind of nerd out on a lot too, is the metrics layers, semantic layers, and where do those fit into the pipelines. I think another thing that resonated when I saw Schemata was just, I think our belief is really these definitions, these contracts should exist as far up front in the pipeline as possible with people producing data. The thing that drives me crazy with the where metrics layer is right now is you're at the tail end of everything. So all you can do is react to all the inefficiencies of the upstream data models, and you can't. Now you're trying to shoehorn in. Oh well, this data is messed up this way. Nothing I can do about it. Therefore, I'm just going to do the best I can. And so you get some really strange definitions, I would say. Some clean ones, obviously, but my ideal world, I'm sure Matt would agree, it's if all this stuff could exist along the food chain, really, it doesn't need to exist in one spot or another, but just from front to end, sort of taking it into account the evolution of varying data needs across the life cycle. I think would be that'd be cool.
Yeah. I think that's a great point. There's a great distinction between, like, I'm just kind of thinking back on that. Like, yeah, I see the metric layer more focusing on the last mile problem, not necessarily the end-to-end schema modeling that what schema are trying to do. Yeah.
That totally makes sense. And I think what we've seen in enterprises, so first of all, with kind of peak Hadoop, what was that really focused on? Well, a lot of it was log ingestion. And that was because there was all this data coming out of applications that was not formatted for analytics at all. And so engineers would have to write MapReduce or later on use Pig to try to pull some value out of those logs, rather than saying to the application team, hey, this data is interesting. Can we record this into a relation or something that's a lot more ingestible? And the same thing with like traditional enterprise ETL teams. They would just expend a huge amount of energy and effort trying to turn raw data into something useful, like just very, very complex SQL code to do that. And a lot of that can be solved by just rethinking the data at the head of the pipeline, basically.
Well, and this conversation came up because we were asking quite a few friends, like, okay, so how do you model streaming data, right? Like, and I think the response we got is, well, where we come from, big companies you've probably heard of, it's like we just assume the data is correct at the source, and we just ingest it, and then I'm kind of like, I think that's a satisfactory answer if the conditions are there for that to happen, but that assumes your data contract is like lock solid and everything's like good to go. But as you point out, these data contracts evolve almost on a many times a week perhaps, and so to assume that your data doesn't need some sort of a model, I would say is, I don't know, it's assuming a lot. It's assuming that people are the upstream people are acting in your best interest, which I don't know that they sometimes are. They probably don't even know, actually. So
I think that makes sense in my opinion, because so in a typical data pipeline, I mean, similar to the CAP theorem, right? Like you have your speed, correctness, and volume. So you can get only 2 out of 3. So when you are stream processing, most of the business requirement I've seen is like an indicative measure of, hey, something might be wrong,
right,
but not necessarily give you the correct result. So that's why data quality in the streaming layer is not well spoken, or partly because waiting for the correctness, the time delay is not acceptable in most of the cases. So your error fixing always happen either as a back process. I mean, either you follow Lambda architecture or Kappa architecture or some variation of an architecture. That's the common pattern that most of the companies trying to use, is to say that, okay, there is an indicative something might be wrong, but I will give you the full fact at some point of a time. I see the data processing frameworks are now improving a lot. I think, systems like Materialize, for example, have a very strong foundation. The data thing, but it's still those pipelines are not designed for correctness.
That's
in my opinion.
yeah.
And I was just thinking now too, like in reality, in the future, it shouldn't just be a feedback loop from analytics to the application layer. It should really be a feedback loop from machine learning applications as well. There are many concepts in machine learning that are very similar actually to analytics concepts. We just attach different names to them. So for example, featurization. What is featurization? Well, we're mapping maybe into a vector space or something, but really it is data modeling. It's like restructuring the data so that now a machine can make sense of it using deep learning or whatever technique. And so presumably this could help in that process as well, as machine learning engineers are saying, hey, we don't want the delay of having to featurize this data later. Can we almost featurize it right at the beginning as it's coming out of the application? Maybe have a separate stream of featurized data so the model can interpret it immediately.
Yeah. And especially right now, it's like the shift is now from a model centric to data centric. So I think that's why these two domains are now merging together. The more data that look high quality data that you feed, the better your prediction right now. So
yeah, that's going to be interesting. And then yeah, I mean that's a separate pendulum that I see just keep swinging back and forth. Like
sure,
it's about the data, now it's about the models, now it's about the data, and then it'll be about the model. Some of my friends on LinkedIn are kind of rallying against the data centric AI movement, and they're like, oh, but it's always been about models and so forth. And I'm like, yeah, it's to me, I just observe things as pendulums. It's like everyone at the end of the day is right in their own way, and at the end of the day, it's also about mean reversion back to probably the combination of the best ideas. So, but it's the one thing on data I've also noted, just to not get religiously attached to ideas too hard, because things just evolve quite quickly. So. Well, speaking of ideas, so what are some of the big ideas you're seeing right now in data? Kind of if you look out maybe 5 years from now, where do you see things going?
I mean, I think the next set of challenge will be similar to Schemata, right? Not because of Schemata, but the major challenge will be how efficiently we do data sharing. Not only within an organization, but across the organization, like across org data sharing. There are certain tools like Snowflake trying to do the data sharing, or Redshift trying to do the stuff. And now that brings a question of like, who can provide the value prop on top of it, right? I mean, my opinion, like it's really interesting to see how those things. I feel like there is an entire new set of startups will emerge on that area. For example, you have the CRM like Salesforce for CRM, or like support ticket for Zendesk. And in the beginning of the conversation, I mentioned like I'm trying to build like the largest customer experience database. Our goal is to kind of, okay, you just bring your customer data here, like your customer tickets, like how MTTR and all sort of metrics. And Zendesk has a domain knowledge of a ticket, customer experience space. They can able to give you a far better analytics and machine learning analytics than you hire someone and dump the data back to data warehouse and build something on your own. That involves a lot of human capital. So there's a specialized verticals of companies, and the data ingestion kind of commoditizing right now, and then the data processing is kind of commoditized. So how far these vertical companies will go and provide the app value addition on top of it, I think that's one thing. Or will they just dump the data back to some well-known data warehouse systems? And will there be some, okay, you bring your own analytical tool and then build whatever you wanted to do? Or will there be any third-party specialized, let's say, okay, CRM analytics as a specialized startup, or customer analytics or customer experience analytics as a specialized startup doing that one, right? So I feel like these three dynamics will be very interesting to watch as the amount of data, and every company is now improving the amount of data they can handle, the expertise, domain expertise they can bring in. I think these three dynamics will be very interesting to see how it's kind of emerging.
Thoughts?
Yeah. I mean, I'm excited to see what happens with data sharing more broadly, because I think we are going to see an era where companies are going to rely less on APIs for data engineering and more on standardized layers such as S3 or Google Cloud Storage or Snowflake or various other databases to share data, especially for like bulk batch data. I also wonder if we won't see like more direct connectivity into streaming systems just to like share data directly, for example, through Amazon Kinesis. You give the vendor Kinesis endpoint and they just dump it in there, and then you can do with it as you will.
Right.
Yeah, and I mean, what I also see happening too is, I mean, assuming you can do a data mesh within a company, I
Yeah.
see the next evolution of that is definitely a data mesh within, a group of companies, right?
Group
So
of
That's
companies,
interesting.
yeah, because right now
Yeah.
data sharing is, I mean, it's definitely a step up from like emailing PDFs and Excel reports to each other, but
Still awkward.
it's like, I mean, it's cool, right? I mean, you give read-only access to data and share it, and I think that's huge evolutions. But it seems like it's just the beginning, though.
It really
Yeah.
does. Yeah.
Yeah.
It's like,
I mean, companies more and more adopting the SaaS applications right now, right? Like, say,
Yeah.
if I'm starting a new business, let's say I'm starting an e-commerce business, I'll sign up with Shopify and get my store upfront aligned with that. And I sign up with, Salesforce, bring my CRM product there, and Zendesk for support ticket system. And you got all those things already set up in the cloud. And whatever the metrics that I'm going to connect, create, like, okay, what is the lead time for me, what is my customer total value, all the data is already exist in 3 different SaaS products. And it's a matter of time people come up with some templated marketplace where you just buy, okay, I wanted to calculate ARR, I'm using Shopify and I'm using Salesforce, give me the ARR pipeline, and I get those ARR insight out of the box. So that 0 to 1 to get those, 0 to 1 for the startups to bridge that analytical gap. Partly, if they use all SaaS product, it's a very standard template. I think there's a lot of momentum will happen on that space.
I mean, this is where there are a lot of startups and companies built around this data integration concept, and I think we routinely see, in a moderately sized company, say a company with 100 million in revenue, at least 100 SaaS products that they're integrating, and we're including things like Facebook ads and Google ads, of course. But yeah, it's still a real challenge to integrate all that data, and especially where you're not going to get any control of those backend systems, unlike an internal application. But I think that's another big challenge here, both moving the data and then getting things like schema and IDs integrated across the company. It's really, really
it's a
hard.
cold start problem every time.
Yeah,
too.
yeah.
There's not like a unified data layer for, okay, I want to join data from XYZ APIs or SaaS products together, right? Like that's still in our experience, at least, very much a cold start thing. There's definitely some companies out there I think are making it a bit easier to join the data sets, but it's still the Wild West. If it wasn't, then everyone would be doing it a certain way, right? And that's definitely not the case. So,
Yeah.
That's interesting.
I would say in this case, like Google is actually doing a fairly good job. I mean, they have a whole host of different SaaS products, and they're kind of using BigQuery as a standardization layer to dump data into. The problem is you have to be on Google Cloud, you have to be using BigQuery, and it only applies to Google products. And so in general, it's just very, very challenging.
That's interesting. What is the next wave of startups look like then in the data space? In your thoughts, Ananth?
I think right now we see a lot of data integration startups, like, for example, ETL or reverse ETL, getting a lot of domain specific. I feel like the next generation of startups will be one layer on top of it. Like, I integrated it. What is the immediate value for me? Like we see that adoption in, for example, customer data platform for marketing side of it, right? So I just connected it, and then like I know how to target more ads and like stuff like that. Similar to CDP, we will be seeing like another domains like a sales. Okay, I just couple this, and this is an immediate value that I'm getting on. What is my lead to kind of close on that, and same for customer experience side of it. Like, so each and every domain will be seeing more and more specialized analytical solution, vertical analytical solutions will come, which include integration. I think integration is like at least in the next 2 years will be like a commodity at that point of a time, my opinion. given the amount of startups and the money is kind of flowing in right now. Hopefully, it's not a problem there.
Yeah.
But I think the next set of value companies will be mostly on the value addition of it instead of just the integration of it.
So less plumbing, more outcomes.
More outcomes, partly because even if you do the plumbing, hiring hiring the human with the knowledge of those domain, like understanding CRM model, understanding customer experience model, and give the value proposition is that the time to insight to train and retain that employees is like more than a year for you. And I think that is the newer startups companies coming in. They wanted to have that edge over, and that's why you can close the gap to compete against well-established companies. So I think the next addition is that layer is kind of missing.
Yeah, I think I think we tend to agree with that notion. I mean, every company wants to. They're not just hiring data engineers for the fun of it, right? It's as fun as it is, and we love data engineering. At the end of the day, you're paid to produce outcomes, and so any tools that could make that easier. I mean, the other thing is too, it's leveraging the fact that data engineers they're really hard to find right now, and even with I would say a looming downturn and probably more people available in the market, it still doesn't I think come anywhere close to bridging the jobs gap that's out there. That assumes that the number of jobs stays static, but that will also go down. So
and also for the data side, we came a long way, right? Like, I mean, we came from a typical reporting use case. And I still remember, like, when I started my career, I started as a backend engineer. I always looked like some of my data warehouse, like, what are those people are doing? I'll never enter into this one. It's kind of a boring, some clicking those UI tools, like that. But like right now, data became the center place, like not only from a business perspective, like a business operation perspective, marketing ops perspective, and also creating this feedback loop and building the maturity of any feature development is like you started with a rule engine. Like if you take, like, that's my analogy, like every business you take, it's a rule engine business end of the day. You define some kind of a business rule to do that, your CRM operation or a customer support, everything is a rule engine underlying. But you'll have a static rule. And then the next layer you add machine learning or some kind of a machine intelligence to make it more robust, right? So the data and the intelligence became the center part of a core differentiator of your business, for all the companies. So the need is increased a lot. So any tool that can bring that immediate value to give that edge I think will have a huge momentum.
I guess in light of this too, what are some things that data engineers should know or level up on over the next few years?
One of the two things, I feel like data integration, even though we're kind of thinking that it'll be solved, I think it'll be going to be remain the huge challenge. Partly because the more and more value addition that we are bringing in, more and more complexity increases or time of it. So definitely there will be a scarcity of data engineers, especially on the data integration perspective. I would say for data engineering, it's largely not the technology problem, largely the people aspect of it. Like how do we kind of bringing people together? And when you are having a product team building some product feature, they're incentivized to deliver the product. It's not intensive to kind of build the data, emit the data and manage the life cycle of the data, right? So most of the challenge will be that side, like how do we bridge that gap? So the data engineering side of it, I would say, like focusing on the integration point, whatever the technology that is coming on the integration point of it, that will add more, it'll give you more run with for the career, I would say.
Yeah, that's interesting. I mean, going back to the conversation about kind of the next gen, what comes after the CDP, more pre-integration platforms. I don't think that's going to eliminate data engineers or even reduce demands, because so you provide an integration tool, companies utilize that to reduce their internal burden, but there are always other specialized internal data problems that are not solved by publicly available tools, where you have to do some specialization.
You're only scratching the surface.
You're just scratching the surface.
I mean, it's sort of like, I think we're only operating like as a field, probably 5-10% of our potential right now. I mean, I see some, so I saw some Slack posts, and was locally optimistic over the summer, fall of last year, but it was like, people are like, oh yeah, data engineers are dead. Like the whole field's dying because like, we have, integrations automated. We have great tools. And it's like, I don't know. I mean, if you've actually worked as a data engineer, I would say that that's just the work changes. It's like anything in this world, right? So, you move up the value chain. That's kind of how it is. I mean, we aren't all riding, horse-driven carriages anymore for a reason, but still got to get from point A to point B, right? So yeah, that's interesting. I guess kind of a follow-on question for new data engineers. We get asked this a lot, and maybe you do too. But what are some ways that you can get into the field and learn about the field?
I think if you're new to the job, the first thing I would say, like, this is try to see through how the business are functioning. Let's say, like, that's one of the things that I always do exercise. If anyone asking me, and is one of my friend also kind of taught me that, like, as a newcomer, as getting kind of asked, okay, go to Walmart and see through how the business operate there, how the shop operate, and tell me what are the data points that you will collect, right? So I think the first thing you have to do getting into this kind of, the way the data engineers see the world is completely different from the way the rest of the people see, in my opinion. So you always see what are the data points you connected, what are the challenges that are collecting those database data and bringing them set. I think that's the first thing, like, improving your perspective and understanding about how the nature of the world works and what are the data points you can get. That's on the perspective, that's kind of a thinking perspective. I think from a pure technology perspective, I would say, like, start with SQL. That's it. SQL and Python, probably one of the best, two best abstraction for data manipulations on top of it. Getting your some basic things. So if you're able to correlate how a business function in the real world, or any system works in the real world, collecting those data point, and the SQL and Python, you can do wonders, in my opinion. So.
Yeah, that's fantastic. I mean, it's funny. It was literally yesterday I was working on the preface of our book, and we were talking about prerequisites, and the two prerequisites we gave for SQL and Python, exactly what you're talking about. And I think during the kind of MapReduce era, people really dismiss SQL. And what I tell people is, like, look, SQL is not the end-all, be-all language. It won't solve every problem, but it's such a powerful tool that can solve problems quickly if you're good at it. It should be your baseline. And then if you have a problem that's not easily solvable by SQL, then you can move on to something like PySpark if you need to, which is where the Python comes in.
But these tools definitely help you understand the concepts too, right? So integrating data, joining it together, delivering it, and so forth. I mean, I would say Python and SQL are both unreasonably effective at, tools for this sort of thing. So I probably wouldn't advise people start out with, I think that there was some literature back in the day, like, oh, you should, as a data engineer starting out, you should definitely learn like Scala, or something like that. And I don't know, go for it if you want, but I don't think that's a good use of your time. So
yeah, I wouldn't recommend to jump onto, like, sophisticated stuff like that. I mean, SQL will cover most of, like, 80 to 90% of the use case, right? So once you got into data in a structured way, you should be able to manipulate in SQL, right? Whether SQL is the best thing or not, that's a different question. But, like, still, it'll cover your 90% of your cases anyway.
That's cool. Talk to me about the newsletter real quick. I mean, we kind of touched on it at the beginning of the show, but why did you start a data engineering newsletter?
That's twofold. It's like, one is like, I was heads down on Slack with the data infrastructure, and then during the last 1 year, I was kind of moving to monitoring infrastructure, trying to build some system on top of it. And I started to feel kind of missing data side of it. I was like, okay, I'm kind of moving away a little bit of it. So you'll have those, fear of missing something. And back in the days, there used to be a data engineering newsletter. I kind of really liked it. And that's one thing that I read all the time, but it was stopped 6-7 months before I was moving to a different team. Then it was funny that initially my thought was like, I want to do a podcast, right? So I told my colleague, and he presented a nice mics for me to do that. And I didn't do that. It's like, it's incredibly hard. It's like you have to do a lot of practice and do that, and like so many things. So I started to write. I'm like, okay, I had to tell some excuse to him. So, hey, I'm writing newsletter right now. Kind of want to do that. So that's how I started, just for fun, and just continue doing that one. Yeah.
That's really cool. What keeps you going? I mean, the newsletters. I mean, it's not the easiest thing in the world to do. I mean, what keeps you going every week on this?
It's really tough, but I think I like to read a lot, and I read a lot. Even growing up, I used to read like 3-4 newspaper as a kid there.
I like this guy.
So so I read a lot. So I like to read it. So for me, that time gives me a focus and understand and grasp and improve my thought process. So as I mentioned, like, writing and the newsletter is just a byproduct out of it. Like, it's kind of my structured note, I would say. Like, I'm not writing newsletter per se to kind of writing the newsletter. So that could be one reason the newsletter sometimes comes very opinionated, but yeah.
What are some of the insights that you've had from writing and I'd say curating a newsletter? I know for us, writing is I think a thought exercise, and trying to really think through your ideas and serendipitously coming up with new ones. What's been your experience with this?
Yeah, for me, writing this newsletter, I just write the summary. So I skim through and like grasp and like add like a 2-3 lines of note. That's what I do in the data newsletter side of it. But if I'm writing down some like bundling versus unbundling stuff like that, so I quickly dump whatever thought I have, or even at the work, like my job, like I used to write tons of RFCs all the time. So quickly dump through everything, whatever the thought I have, and then slowly started to structure it and read through 2-3 times to understand whether I kind of structure it properly. And the last to read, I would put somebody else's shoe and say, like, okay, this is my target audience. Will they able to understand this particular narration? So when you're writing, it's essentially you're telling a story to convince someone. Is that a story has a structure that have a continuity between those two things? The last to read, I try to do that. So if I'm trying to write an RFC or trying to do an article or something like that, I'll definitely take like a 4-5 days minimum to kind of write it down. So I initially dump everything and just let it off. 2 days I will not touch. The third day I'll go and kind of see what you have to do that. So it's a long process.
Mm-hmm. That's really cool. Here's the newsletter here. Thanks, Colleen. Sign up, dataengineeringweekly.com. So yeah, thanks.
Okay. Thanks so much.
Yeah. Where else can people find out more about you?
I'll be on Twitter at Ananth Packkildurai. That is my Twitter feed. So
nice. And Schemata app as well. That's cool. Any parting words for the audience? Or?
Yeah, Schemata is something that I'm kind of thinking, see more and more thought into it. So yeah, I'm looking for any interested contributors who wanted to discuss more about that and understand or kind of adopting in your org. Really curious to talk and understand what other problems the different companies are facing. So anything, like not necessarily Schemata. If you wanted to talk anything about data, bring me, ready to do that all the time. So
bar charts versus pie charts. No, I'm just kidding.
Bundling versus unbundling.
Bundling versus unbundling.
Yeah.
That argument won't go away, will it?
not on Twitter, it won't.
The bundling versus unbundling will move from one area to another area, but it will never die. It's like
there's just Twitter as well. Yeah, that was an interesting debate for a bit. I guess we'll find out. I think the decision is going to be forced for a lot of companies really soon. Unfortunately, depending on what side of the deal you're on. So, but consolidation does happen. This is just kind of how it is. And but like I said, I think a good theme is just it's a pendulum. Things get bundled, things get unbundled. That's always how it's been too. So it's
right.
Yeah, that's what it is. Well, cool. Thanks, Ananth. Also, Monday morning data chat. Next week is Memorial Day in the United States. Next Monday, that is. And so, I don't know. Are we doing a show maybe you pop over, we do a show, or maybe we don't. I don't know.
Yeah,
So,
let's think about it, or maybe we consider doing it on Tuesday or something.
Tuesday.
We'll
Let's have a
announce
Tuesday
something.
morning data
Yeah,
chat.
yeah.
Monday
Tuesday
morning
morning
data
data
chat.
chat. We'll just call it the Monday morning data chat. It's a
Just-
radical notion.
It's Monday somewhere. Yeah, and then coming up, we got Igor from Big Eye. We got some other cool guests. Let me see on my calendar. Jesse Anderson. He's going to be on the show. Yeah, Igor, Jesse Anderson. We got Ethan Aaron. We got Laszlo Srenger. So some heavy hitters. And yeah, throughout the summer, we got actually quite a few. Justin Borgman's coming on the 18th. We got, I think, yeah, quite a few people. So that doesn't include our Friday show either. So stay tuned on more announcements. You guys got a pretty fun crew showing up. So awesome.
Awesome.
Yeah, man.
Great.
It's good to chat again. So
Great to meet you, and yeah, look forward to talking again soon.
yeah. Awesome.
Yeah, great to meet you. Take
Yeah.
care.
Thanks to the audience for the great questions. We'll see you next time. Bye.
Yeah, bye.